Good afternoon, everyone. It's 3:05, so we'll start. Uh, First, confirm whether am I audible or not. Can somebody confirm? Am I audible? Yeah. Okay. Okay. So let's start. Welcome to discussion session of sixth week of the course Finite Element Method, course offered by NPTEL, and the course instructor of this course is Professor Biswanath Banerjee and Professor Amit Shah. Myself, I am Asif Raza. I am a PhD scholar from Department of Civil Engineering, ISC Bangalore. So today we'll be discussing questions relevant to assignment number 6. Okay, so before starting discussing questions relevant to assignment number 6, I had to tell regarding the last week's discussion. Uh, so this was one question uh, where we had to write the Euler-Lagrange equation for the functional uh, having function of like f of x, y prime of x, zx, z prime of x. Now the question was asked like what if our independent variables are multiple? So the question was what if my functional is f of x, y and z of x comma y, then z of x, x comma y, and z of y, x comma y, where zx of x comma y is dou z upon dou x of x comma y. So that is understood, and the this is dou z of dou y. So I told how do we proceed. So when we take the variation of this functional, we get what f by dou z plus dou f by dou zx dou zx plus dou f by dou zy dou zy. Here we had to substitute this dou zx and dou zy in terms of z. We had to convert this all the these second and third terms in terms of this thing, so that we can take out the common factor and integration can be done easily. So what do we do is take this, so this will be this. I think you guys don't have any issues to this, uh, or maybe I'll elaborate it properly. So this is coming. We take a chain rule. We are taking a chain rule for this. Dou f by dou zx dou z is what we sorry, not chain rule, product rule. So This is what? This is uh, the equation, and we need to substitute for this part here, right? So to get this, to f by tau zx, we just take this term to the left hand side. So we'll get minus dou by dou x of dou f dou zx dou z. Similarly, for with respect to y, we substitute it, we'll get this. Okay. Now the function. Now the functional is what? F of x comma y comma z comma y z x of z y of x comma y. So this variation is f of in the domain. This is what is there. The variation will give me this dou f by dou z plus dou f by dou zx dou z dou f by dou zy dou zy d omega. And then we substitute what we found earlier. So let me write it with different. So that was dou f by dou 8, yeah, minus dou f dou zx dou z plus dou by dou y dou f by dou z y dou z minus dou by dou y dou f by dou z dou the domain. So we take common thing, this one. So I'll write it dou f by dou z minus dou by dou x dou f by dou z x dou z minus dou by dou y dou f by dou z y. Okay. So dou z. Okay. And other terms are, okay, so these are in the d omega plus omega dou by dou x dou f by dou z x dou z plus dou by dou y dou f by dou z y dou z d omega. So this will give me the Euler-Lagrange equation, and this will give me the boundary conditions. So Euler-Lagrange equation will be finally, like when we integrate it, like we'll take this thing using the arbitrariness of z, we'll get the Euler-Lagrange equation as this. So this is what I was telling you. Okay, I hope this clarifies earlier doubt. Now we'll move on to today's discussion. Okay, so first question is, consider the following frame AB and consider node A as initial node. So you better see, this is my initial node and B as final node. Find the transformation matrix TE corresponding to the member AB. So I know that it's relevant to assignment number 6. There the angle was given as 45 degree, but I think something was uh, so here my A is the first node. As you know, all that transformation matrix is written as cos theta sin theta minus sin theta cos theta 0 0 0 0 0 0 0 0 cos theta sin theta minus sin theta cos theta when my members are like this. This is for 1 2 and this is 1 2, this is theta here. So 1 2 3 4. Okay, so for that we get the transformation matrix as this, but the question asked is that we have the member A B and our initial degree of freedom are like this 1 2 3 4 and theta is equal to 30 degree. Yeah, so okay, I'll just write 30. So if you want to use the same transformation matrix, we need to identify what our theta will be first of all. So with this aspect, our theta would be like our first 1 2 3 4. So uh, the question in like here the theta was taken from the 1 to the member. So if you take the similar thing, our theta would be this. Okay, and how will we find this theta? So here is 30 degree, so this will be 150 degree. So a theta would be equal to 360 degree minus 150 degree, that will be around 210 degree. Yeah, so now just we need to find cos theta, and that is cos 210, that is cos 180 plus 30, this will be minus cos 30 and that is minus root 3 by 2, and the sin theta, that is sin 210 degree is this is minus sin 30 and this will be equal to minus 1 by 2. Now okay, so when R 1 2 3 4 is numbered like this, but here we have 1 2 3 4 5 6, the theta also, you see. So with that in consideration, transformation matrix changes cos theta sin theta 0 0 0 0 minus sin theta cos theta 0 0 0 0 0 1 0 0 0, and here it will be like this. Then here cos theta sin theta 0 minus sin theta cos theta 0 0 0 1. Okay, so my transformation matrix will come out to be cos theta h minus root 3 by 2. This is minus 1 by 2. This will be 1 by 2. This will be minus root 3 by 2. 0 0 0 0 0 0 0 0. We'll just write the non-zero term. Minus root 3 by 2 minus 1 by 2 0. This will be 1 by 2 minus root 3 by 2 0 0 1. Symmetric. I'll just write it here. So with this, correct option would be uh, minus root 3 1 by 2. So correct option would be option A. Yeah. No. Here it should be minus 1 by 2, right? Minus 1 by 2 is there. So answer would be this. Yeah. Minus would be minus 1 by 2 minus here. Yeah. Option D would be the correct answer. I hope nobody has doubt in this. Moving on to the next question. This I'll ask you all. So, in finite element solution, after assembling all stiffness matrix and force vector, the equilibrium equation looks like KUU KUK UU FK, then KKU KKUK FU, where U subscript U is unknown degrees of freedom and U subscript K is known degrees of freedom. Consider the following beam and find the size of KUU and KKK matrices. So options are provided. What are the guesses from you all? I hope the question is clear. I expect answers. I'll just magnify it if it is not visible properly. Yeah. Rafael has said option A. Others? Abdullah has said option C. Rafael again corrected himself and said option C. Abraham? Option C. Yeah, correct option is option C only. So here, so the problem in consideration is this one, right? So if you see the problem, what are my known degrees of freedom? So UK will be what? 1 is known because that will be 0, 2 is also known, that will be 0, 3 is also restricted, and 5 is restricted. So these are known degrees of freedom, and unknown degrees of freedom is 4 and 6. Okay, now so if you see the size of UK is uh, 4 by 1. So these are like transfer. We should take it as a transfer thing. So you would be 2 by 1. Okay, 1 2 3. Now see, so okay, so we have KK, we have KK KU, sorry, KUU KUU KUK KKU and KKK. This is UU and UK FK FU. Mhm. Now see this. Okay, so if you just see this thing, multiplication would be done what? K uu times uu plus k uk times uk, right? These are blocks, these are vectors, and fk would be there. Similarly, k ku uu plus k kk uk, that will give me fu. Now one thing is the dimension of uk would be same for fu, so that will be also 4 by 1, and f k would have the dimension of uu, that will be like 2 by 1. So if I write the dimension, this is 4 by 1, this should also have 4 by 1, this also should have 4 by 1, this should be 2 by 1, 2 by 1, 2 by 1. Now let's see this. K U U U U. This result should be 4 by 1, right? And UU has a dimension of 2 by 1. Sorry, did I make a mistake? SK is 2 by 1. Oh, this is 2 by 1. 2 by 1, 2 by 1. This is 4 by 1, 4 by 1, 4 by 1. Okay, so the result is 2 by 1. UU is 2 by 1. So what should be here so that my result should be 2 by 1? It's naturally it should be 2 by 2, right? 2 will contract with 2 and this 2 to give this result. So KUU has a dimension of 2 by 2. Now take this one, K KK UK. The result is 4 by 1. UK has a dimension of 4 by 1. So the first thing should match with this, so that will give me 4, and second to get contracted it should match with this, so this will be 4. So this gives me KKK will do 4 by 4. Okay, so with that my answer is option C. So now if I ask you what will be the dimension of KUK and KKU, you guys can type in the chat box or you can unmute and answer. Am I audible?
Yes.
So expect answers. Okay, so Abdullah has said KUK as, okay, I'll just write. Abdullah has given an answer as KUK as 2 by 4 and KKU as 4 by 2. Oh, sorry, KKU, right? You mean KKU, Abdullah? Yeah, okay. Hmm. Others? Others, Jess has said same. Uh, what about Rafael? Rafael, are you there?
Yes, I'm here. I believe it is the same as Abdullah.
Uh, okay, I think all the guys are wrong. I think you guys are mixing it up. So I asked KUK and KKU, right? So for KUK, you'd say this one, this one. What is that? K, this K, KUK times it's okay, okay. Uh, you guys are correct, I would say. Uh, yeah. KUK is 2 by 4 because UK is 4 by 1. Yeah. So all of the guys are correct. Now let's move on to the next question. This is consider the simply supported Euler Bernoulli beam which is subjected to different loading condition. Beam 1 is subjected to point load at center, beam 2 is subjected to uniform load, beam 3 is subjected to linearly varying load, and beam 4 is subjected to parabolic loading. The beam is analyzed with two node element and each beam has two number of elements. So which of the loading condition will cause highest and lowest errors? I expect quick answers because I think this is already there in the assignment.
C.
Option C. Yeah, Abdullah has also said option C. Yeah, so yeah, correct answer is option C only. As it has already been said, but let's say so. The question in this question we take two node beam element, right? So this has an approximation of 3 degree, 3 degree, right? And our uh, problem for beam 1 has a deflection degree of 3, beam 2 has 4, beam 3 has 5, and beam 4 has 6. So when our approximation of the displacement takes into account of only 3, so the exact values or the error having a minimum will have in this and maximum will be in the orders degree of 6 one. That is my problem number 4. So beam 4 will have the highest error and beam 1 will have the lowest error. Now let's move on to the next question. Identify the incorrect statement. Uh, question statements are, the first statement is the transformation matrix is orthogonal in nature. Second option is stiffness matrix is invertible. Third is truss member can carry axial load only. And fourth statement is for two node frame element size of stiffness matrix is 6 by 6.
Stiffness matrix is not invertible.
Okay,
B is wrong.
so you are saying option B is the incorrect statement. What about others? Abdullah has said option A. Uh, Please do check the question says incorrect statement.
Transformation matrix actually orthogonal.
Yeah. Jess, what about you? Option B. Okay. Yeah. So the incorrect statement, or rather, jumping into the answer. Let's see one by one. So first statement says transformation matrix is orthogonal in nature. It says if my transformation matrix is T and I multiply it with T transpose, it gives me identity and it is true. So correct. First statement is correct. Second says about invertible. Uh, that is wrong. Stiffness matrix are not invertible. These uh, become invertible after imposing boundary conditions. Truss member can carry axial load only. That's true. And for two node frame element size of stiffness matrix is 6 by 6. So if my element in consideration is two node, so one is uh, okay. So better for a general two node element. So U1, V1, U2, V2, and theta 1, theta 2. Right. So this is what 6 by 6. Okay. So with that, our incorrect statement is option B. So the correct option is option B. Okay. Let's say there's a similar question which was there in the yeah. So this question, which is the correct property of an elemental stiffness matrix?
Stiffness matrix symmetric in nature.
Okay, so you're saying stiffness matrix is symmetric in nature. So, as just now we said, uh,
AD, it is options. They are the same in nature.
yeah,
Stiffness is not invertible. Determinant is zero.
yeah, yeah,
Trace also is not zero.
yeah.
Actually, what does it mean? Trace is not zero. How trace? Uh, if
Okay,
trace is zero, it is what does it mean for operator? It's trace zero. What does if matrix has zero trace? How it acts? Why this important?
uh, okay. For this, got to see. Um, uh, I have one minus one minus one one, and if I have one minus one, something like this. Okay. So, would it make any change? I had something in my mind. Mm, uh, okay, let me say something about this. Mm, okay, uh,
Sorry,
X. Yeah, just a
I mean,
second. Okay, so x transpose kx should be uh, like kinetic energy can always be positive, something like this. So v transpose mv half and uh, mm, mm, kind of x transpose kx, uh, this should be greater than equal to 0, and uh, you're saying something, Rafael?
No, I just as you have some in my mind, but I don't remember
Yeah,
because this is about orthogonal. This is about positive definiteness.
yeah. I think this is related to energy, uh, physicality of the energy thing, but I can't. I'm not able to pinpoint exactly. Uh, I'll try to work it out. I'll try to search exactly what is it. Yeah, and say it in the next discussion session. As like earlier, I said about the two independent variable thing. Okay. I would like to ask a similar question. Like this one was the question regarding the element stiffness matrix. So what if I change this question? Which one is the correct property of rather than element stiffness matrix? If what will if I replace it with global stiffness matrix? So what will happen to the answers?
Global matrix is not invertible, as an elemental trace is not zero. Stiffness matrix will be symmetric, and determinant will be zero because it's not invertible.
Yeah,
Because it's not invertible, yes.
yeah. So even if we change the statement from elemental to global, our answers would be the same, as said by Rafael and Abdullah as well. Okay. Now let's move on to the next question. So this was the question. It was more complex in the assignment set. I'll just roughly go through rather than going into the deep. This is the question. Consider the following continuous Euler-Bernoulli beam and answer the following question number 5 to 7, but we'll focus mostly on the question number 5. Each segment of the beam is discretized with two elements. Global degrees of freedom are shown in red. Loading of the beam is shown in figure, that is 12 kilonewton per meter. It's fully loaded. And consider constant TI. You need to use the constant to solve this problem. Okay, whatever. Now the question is, after assembling all stiffness matrices and force vectors, the equilibrium equation looks like this, where u is unknown degree of freedom, uk is known degrees of freedom. What will be the joint load vector qk? This one. Degrees of freedom are arranged in ascending order 3, 4, 6, 7, 8, 10, 11, 12, 13, 14. Uh,
Are we going to discuss some code here?
do you want me to?
Of course, because this code they provided, I, I
Okay.
I wrote own code, but it works like something. I wrote it by myself. For instance, I have several questions regarding the code.
Okay.
Upward first degree of freedom.
Yeah.
Does it mean we need to change it q to minus?
Yeah. Yes. Yes. Yes.
It's make a look. It was a very tricky question.
Yes. Yes. This is what it makes the
I
difference,
have
right?
mistake here
Yeah.
because they change science again, and
Yeah, so you're saying
This is you know in compare with guys in another course, they never change science rule because it's very difficult to when you trying to trying to know how
no,
finite
but
element works. The chicken is in the science. It's
yeah,
not
but
honest. It's not
uh,
fair to change science rule again and again.
no, first of all, this sign thing is uh, user dependent, right? Like, if this user is taking this upward sign as positive, I could have taken this downward side as my positive sign as well. But so it's quite natural that you need to see what is the thing they have taken in the question or something like that. That then only this is like minor thing, but this makes a lot of difference in our solution.
Okay, I have solved with positive sign, and there were a lot of uh, disagreements with the answers. So I just sit and fitting two answers. After solution after several days, I understood that Q should be negative. So it was
Okay, you
this
I
was a problem.
okay, okay. I'll just
My first questions regarding to code is how we should write compatibility here, or I forgot how they call it.
I'm not getting your question.
Connectivity matrix, or connectivity of the elements in the beam case. There are two lines in code. Do you have a code
Yeah, yeah. So
that can share?
uh, it's beam FEM SEC, right, or a frame?
Yes, yes, beam.
Just a minute. Hmm.
Element connectivity.
Yeah, yeah, yeah. I just need to stop here and share from different. Just a minute. This one, right?
Yes.
Okay. So uh, this.
Do you have ability to do you have ability to numbering your rows in your reductor, in your
I
text reductor?
I am not getting what are you saying?
Uh, do you have ability to show the number or the line in your text reductor
Yeah.
to
So you're
default?
saying this one, right? Oh,
Okay, this one. Yes. No, there is no ability, I believe.
so you're saying this one you are talking about like element connectivity. How has it been done?
Yes, we have three elements here. How we should
No.
and how we
Uh,
should write collectivity here. I don't understand. For three elements.
uh, just this is just for how should I say? a single element, right? So this is for a single element, I say, yeah. So this element connectivity, the uh, first thing is how are we getting this thing? So a length of the node and mm, this one, this one gives me x x values, I suppose. No, no, no.
Do you have ability to
Yeah,
uh,
if I
just we can use Octave online and up to this line and see what this gets, what it gets, what
actually I have MATLAB. I haven't installed. Uh, I have to see this thing. Okay, let me see once again. So element is a length of nodes. Okay, so this see these things will give me x coordinates, and this will give me x coordinates. But this one with respect to my first node and this one with respect to my second node. Mean to say, see, what will this line give me? Uh, the these both lines are giving me element uh, uh, coordinates actually, right? These both are giving me element coordinates and mm, no number.
can we just run this code up to this line to our problem that we have?
Is okay. Let me see.
We have three elements. We need to change n to 3 as I understood.
But in my problem which I was sharing,
Sorry, you have another problem
yeah,
from previous year.
yeah. So this was having like
Three
one,
elements,
2, 3, 4, 5, 6 elements.
6
Yeah.
by 6.
If you see the question says
See, I see that. Yes.
each segment with two elements. So here it will be one, 2, 3, 4, 5, and 6.
Okay. We need to write 6 elements. And
Okay.
L is equal to 6.
1 is to 1 is to length of code. So if here my if my number of uh, nodes are sorry number of elements are 6 here, then 2 2 4 2 6 here. So here it will this statement will give me what 0 uh 1 2 3
Look, I just ran this code up to this, and the first element.
You better share your screen because
Okay.
I'll just stop sharing mine.
Can you see my screen?
Yeah.
I just ran this, as you can see here, up to I enter this n is equal to 6, and after that I
or in that
did that. Yes,
element
and we can
connector.
and we can see what is the element. I now
Yeah, yeah,
I'm
I can see now 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7. So, okay, I'll just try to explain here. If you can see,
uh, the question is in in our beam element we have 2 degrees of freedom for each node. How it works here?
no, that's just an element connectivity. That's not node connectivity yet. That was element
Ella,
connectivity. Element connectivity. So if we have 1, 2, 3, 4, 5, 6, so 0, 1, 2, 3, 4, 5, and first, second, third, fourth, fifth, 6, and this one is 6. Right. Element connectivity says 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6. Right. So this is for, like, am I correct in here? 0 to 1 also. 2, 3, 4, 5, 6. Yeah. So what does this says that uh, this element connectivity says my first, I hope I'm not making mistake. Rafael, can you share your screen once again?
it starts from 1.
Why?
Okay, I can share. I don't know if you ask here.
Okay.
Who
Okay.
have
1
written?
to 2. Yeah, yeah, I'm saying 1 to 2 and 3, 4 elements are 1, 2. Mm, uh, I'm just confused here because it has a different numbering system, right? Like Python only, it starts from numbering from 0, I suppose. Or it uses like an MATLAB only, where
In
they
MATLAB starts with
1.
1.
Yeah.
Yes.
What about Octave? It starts with 0 or 1.
Octave is just MATLAB for free,
Okay.
and Skylab is also.
Okay, so why then mentioning it is like this? It should be like this. 5, 6, 7. Then it will make sense, right? Element having 1 to 2.
We don't see your screen.
Oh, sorry. So it should be like this, I think. 2 to 3, 3 to 4, 4 to 5, 5 to 6, and 6 to 7. This should be because if it is has if it has the same numbering scheme as MATLAB numbering starts from 1, so node numbering should be like this, and element should be like this.
Okay, node starts with 1. Node starts with 0.
Yeah.
It's you can see nodal coordinates. But by the way, it's nodal coordinates might be. It's coordinates like where is our global axis is. Where our global axis where our global axis is here. It starts with 0. A professor said that node it is the coordinates of our nodes. So it starts from 0 because left node is in 0.
Okay, that's not like the node numbering.
No, nodal coordinates. It's
Okay.
coordinates with respect to global
Okay. It has written node.
axis.
Yeah, comment in the comment section. Okay, share screen. So yeah, so it says here nodal coordinates. So this will be like nodal coordinates, like node 1 will be having 0, then here 1 2 3 4 5 6. Okay, there. Now this says 1 is to with iteration of 1 to the till to the length of node. So this is like 1 2 3 4 5 6 7 minus 1. Okay, length of node minus 1. This is equal. So from here 1 to 6 here, and here uh, 6 to 7. Okay, now this makes sense. So see this, if you are seeing the screen, uh, uh, this here element bracket all comma 1 gives me the nodal coordinates, uh, like uh, first nodes actually, whatever the element we are taking, the first nodes. uh, if I don't know, this one is not said. So what does that mean is element 1. So suppose whatever the elements we are taking, first element, second element, every element has an element stiffness matrix. For that we have node 1 and 2. So node 1s are being, for every element node 1s are written here. 1 is to 1 is to length of node minus 1. So this will give me what for every element uh, in the first column. So this will give me the result as 1 2 3 4 5 6 till the length of node, that is 7 minus 1 6, till 6 only. And element 2, this is like from 2 is to 1 is to length of node, right? So this will be 2 3 4 5 6 1. So this is yeah, so the code also says the same thing, that this first element 1 has the nodal connectivity node 1 as its element node, like there is a global node and local node. So local node 1 2, and these are numbered as global node. Okay, I hope that makes sense. Now let's move on to the other part of the code.
Okay, I believe the discussion about code questions should be delayed because I'll have a lot of questions beside to code. What did you want to show
Ask,
us
yeah, yeah, yeah.
about last questions?
Okay, I'll just move this one.
This is actually I don't know. This question is easy for me, but if guys need to this question, but if guys need to clarify something, I can wait.
Okay, we can discuss more in the end session today, the, during the end. Or after this, I'll just start asking or discussing questions what you have doubt only, rather than solving further questions. So, okay, so we'll just solve only at least this question number 5, then we'll move on to the discussion of the doubts. I hope that is okay. Mm, so the question here is saying there are 6 elements and total degree of freedom is 14, and the question asks what will be my joint load vector qk. So we need to find qk here, right? So if I take the first element, like say just clean it here. First element, this one. So for this uh, element 1, q1 1, q1 2, q1 3. I'll just write like this, q1 4. Okay. mm, yeah. So what will be my q1 1? That means this one, and
Here
that,
we have reaction.
so that yeah, what did you say?
In this first nodes, we have a reaction. It is
Yeah,
unknown.
yeah, yeah, yeah. So those will be unknown thing. So I'll just take this thing as it is, and q13 and q14, those things
Will be zero.
0. Yes. Similarly, for element 2, we'll have q1. Okay, for this one also, just q21, q22, q23, q24, or rather, I'll just write the degree of freedom 3 4, 3 4 5 6. That is okay. So this will be equal to 0 0, and in 5 and 6, 5 will be unknown. I'll just write it like this, q6 will be 0. Element 3 will have, now I'll just write it directly. So 5 6 5 6, then this will be unknown, this will be 0, and 7 and 8, those will be 0. Element 4, 0 0, and we have 9 positive, but that will be unknown. Unknown q4 9, and we have 20 kilonewton meter in the anti-clockwise direction, but our positive sign is in the clockwise direction, right? So that this will be what, minus here. Okay, I'll write it here only. Element 5, this will be q5 9 minus 20, then uh, this will be 0, element 6, or rather I'll just write it here as q410, q510. Okay, and element here also I won't just directly write it 0. It's better keep this thing here only. q36, q37, q38, q47, q48, q49, q410, q59, q510, q511, q512, q611, q612, q613, q614. Okay, so when we assemble it, our q thing will have q11, q12, q13, q14, then plus q23, q24, q25, q26, then q35, q36, q37, q38, here q47, q48, q49, q410, q59, q510. I'm taking a lot of time here. q5 6 11 and q6 12, q6 13, q6 14. Okay, so what will have, this one will stay as, I'll just write it as q1, this one as q2, this thing becomes 0, this also becomes 0, right? 3 4 5 stays as it is, so this will be q5, this one becomes 0, then 7 and 8 will be 0, 0 and 0. q9 is unknown, so that will be there as q9, this one as minus 20, this one as 0, this one as 0, and last 13 is minus 10, and this one is 0. So with this, our known thing, our known qk would be what, 0 0 0 0 triple 0, then minus 20, then 0 0, minus 10, then 0, transfer. So this will be my answer. So this will be the answer, right? Yeah. Okay, for further Let's see. Rafael, you wanted to ask us. I won't ask now further questions, but I'll just solve your discussion. I'll solve your doubt, whatever doubts you have. Okay, so you can proceed with the question. Rafael.
Yes,
Yeah, so you had doubt somewhere else.
I have doubts about something in code. It's not
Okay,
clear.
so which code? This Beam FEM only, right?
Uh, Globally, for each code, I don't know how indices of unknown. I haven't catch the idea. What indices of unknown power should give me.
Uh,
Uh, the- there in Trust code and in Beam code, there are parts of the code where we need to return indices, and I don't know the idea of that. I don't understand the idea. What should we do in this part?
uh, in the boundary condition part, you're saying.
Indices, where we should and where should we this part of codes return me indices.
Okay, I'll just share my screen.
By the way, any questions about trust? We have trust problem there.
Yeah, I do had. So you had doubts regarding that also.
I don't know. I don't have the I don't know what we as I understood in future assignments we will be provided with some code,
Yeah.
and the lecturer said you need to understand how this works, but in lecture um, there's no
Working.
details. There are
Okay.
no
Yeah, yeah,
about there's no details. It's not very clearly detailed. So I try to go this code line by line and understand what it should give me.
okay. I'll try to go through the code
In the
if I'm
future
able to.
assignments, what we should do? Do we need to
Uh, it, it,
understand all code in details, or we have just we need to use it in order to obtain some, in order to get some answers with that.
what I would suggest, it's best to take a simple problem and just apply the code there and try to see line by line, like what is that is giving it, like what is particular thing is giving you the result. Let's go through this Beam FEM code itself.
Okay.
So that we can have an idea what it is giving it. So I hope the screen is visible. Okay, so this is like analysis of beam using FEM nodal coordinates. So this will be the length of the complete thing. These are number of elements, and these are like the one element will have what kind how much length, elemental length this will give me. Now this is what will give me the nodal coordinates for starting with 0. Okay, now element connectivity, this is uh, this thing gave me like this first line is giving me the local, uh, everything is giving me global nodes, but these things are local node 1 and these are local node 2 for the respective elements. As you uh, you can share your screen parallelly so that I can present on my screen. Rafael,
Yes.
can you share your screen with the code so that whatever you run, I can also tell something about it.
Okay.
Yeah. Just a minute. Okay.
I should I run it?
Okay, so you can just maximize that code command, that n-
Sorry, I can do it by MATLAB.
yeah,
Yes,
let it be this thing
it's
now.
just okay.
Okay, so see, if you see that line number 15,
Line number 15. Yes.
yeah, uh, we are clear till line number 12. I hope everyone is clear. Rafael, you are now clear
What?
till line number 12, code line number
12?
12. Yeah.
12 is clear now.
Yeah, okay. Now let's see line number 15. Line number 15 says number of nodes. Num node is, you just keep
Let
it
me.
there. Okay, you just keep it
Okay.
as of now here. You're saying line number 15 is num node, that is length of node. So length of node is like total number of nodes in our question. So total number of nodes in our question is 7.
Se-
As
7.
yeah. So if you type that in the command now, it will give me 7 for our problem. Now the 16th a number of elements. So this is like size of element comma 1, and size of if you see my element matrix came out to be like uh, it has a number of rows as 6 and number of columns to be 2, right? So if you see the size of element, this final thing,
Okay.
yeah. So you're saying octave 9, yeah, it's there. Element is equal to 1, 2, 2, 3, 4, 5. If you type size of element there,
Let me do it. This is a comment section. It's a Scilab. It's not working Octave
okay.
as a comment section.
Okay. Let me see if I can open my MATLAB. Then can
This
try.
is not MATLAB code. This
No,
is
no.
Scilab code. Okay.
Okay. Won't it work in the MATLAB? I
It
don't know.
will work if you change this comment section properly. It's not a. I can try to open my MATLAB.
No, no, no. Leave it then. Leave it then. We'll work in the octave itself. So
Okay,
now,
this is num node. Num node. We can just num node. Is this 7?
yeah.
Num
So
elements
num element will come out to be
6.
6.
6. Num dot.
If you just see write size of element, size comma element, sorry, size open bracket
Okay.
element, open bracket element, and closing bracket. No, not necessarily. I just tried. I want to say something about it. Remove 1 comma 1, remove it.
It will. I know this command. It provides
Complete, huh? It will give me 6 by
it
2.
provides the size of 6 too. Yes, I
Yes,
understand
6
this
2.
size. It's
So
MATLAB usual command.
when we
Six
say
columns, six
com
six rows and 2 columns.
yeah, so comma 1 we're saying like how many rows we have. So we have 6 now. So that clarifies number of elements. Now line number 17, if we say number of degree of freedom, so that is how much it will be. It will be like number of nodes multiplied by 2, right? So that gives me
Okay.
what? 7 to the 14. Better leave it. Better leave it. Close the MATLAB. Okay, so line number 17 clear. Now line number 20 and 21, if you see, we are just providing what will be my Young's modulus and second moment of inertia for each element. So in this question we have just providing value as 1 1 for every element. There could be a case that we could provide a different ei's for different elements. For that you have to write it separately, like for e1 what you want to keep, for e2 what you want to keep, like for a particular element. I hope that makes sense.
Okay.
Okay. Now coming to the boundary conditions. So if you see line number 24, boundary conditions, here it says 100. So in the comment you see there's, it's written node number, transverse and rotation. Like
I understand this, by the way. We have I understood this. We need to fill our boundary conditions for each node.
yes,
Uh,
yes.
but your problem is different. I need to
No, no.
see again.
Yeah, that could be modified to this thing only. Okay, so you can just keep it as it is as of now.
If
Let's
we
see.
if we consider your problem, it will be what? Can you share?
So my question. Okay, just a minute. Is it visible? Okay, just start sharing. Yeah. So this was the question. So
Okay, let me try to fill boundary conditions here. Uh, it's we need to choose nodes,
node and first is node number, and
node
next
number.
one is
Yes.
transverse. Transverse means like vertically how are you
Yeah, yes,
restraining it,
yes, yes. I
uh,
understand this.
and the second. So
It will be the second. It will be the third node here. Third node. The transverse is restricted.
no, 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 no,
Zero.
no. Yeah, yeah, yes.
It's restricted. This one is not restricted.
Rotation is
We
not
have a
restricted.
more
Yes,
restricted. Yes.
yes, yes.
After
Next
that,
five.
we need
Go to five.
uh,
Five.
five. It
Just
is again is restricted. Is not restricted.
1, 2, 3, 4, 5, 6, 7. So boundary condition is 1, 3, 5, 7.
And then one, two, three, four, five,
No, but uh, don't we
one.
need to restrict everywhere? Like, don't we need to specify boundary condition at every nodal points?
We need to restrict only essential boundary conditions here, as I understood. It says two, three, four, five, six,
I have
seven.
said in my screen also.
I believe we need to restrict only essential boundary here. We should mention this.
Okay, so in that case, you just need to write 1, 3, 5 only.
I believe yes, as I understood.
Okay, no, but I still feel okay. Leave it. 1, 2.
You think that we need to write two, one, one, this one?
Yes, yes, yes.
Maybe the case, but in the example problem that professor solved, he filled only essential boundary
No,
conditions.
but was it like uh, mm, kind of this we are having nodes in between. Did it include that also? Whether that problem had this kind of thing? What I mean to ask is this thing. Uh, okay, let's move on. Let's try with this thing also. 1, 2, 3, 4, 5, 6, 7. You just apply all the constraint there.
I need to remove constraints, do you think?
Yeah, like no constraint. Just say 2, comma. Sorry, 2, 1, 1. Then 3, 0, 1, 4, 1, 1. Then 5,
Okay.
0, comma 1. Then 6, 1, 1, 7, 1, 1. Okay. Now coming to external forces part. External forces says length of node minus 10 minus 15. Okay,
This is
this is just where we need to apply load, that node number, shear and moment. So this I don't feel this is tough. This is line number 28, right? In line
yes.
number 28, that q equal to length of node where it is written, the first thing would be node number. So if, in our problem, if you see, load is applied at node number 5 and 7. So just write it at node number 5. It's shear. Shear is no shear. You just write 0. 5 0, you have written minus 20. Yeah, okay. And in 7 it will be minus 10 comma 0. Yeah, okay. Now next part, moving to the next part, where its fx is equal to minus 10. In our problem it will be minus 12.
Okay.
Minus 12. Yeah, okay. Now uh, next part, initialization of stiffness matrix, displacement vector and force vector. So if you see first line number 34, that is like we are just providing global uh, displacement vector. U is equal to, like, first of all we are initializing, so we are keeping 0 0 0. Total degree of freedom is 14, so 14 zeros, uh, 14 row of zeros and only one column. uh, for the global stiffness matrix, that will be 14 by 14, and global force vector will be also 14 by 1. Okay, so there I think we don't have any problem. Now
No
moving
problem.
to, yeah, so moving into the applied load, q at degrees of freedom. So for I equal to 1 is to size of q comma 1, size of q comma 1. Okay, uh, yeah. So if you see, like
Yes.
we need to apply the load. We need to these are uh, like line number 28. Those were external forces, right?
Yes.
So those were like applied loads that need to be integrated in that loadal vector, global loadal f vector, and that is how we are incorporating in line number 41. So how we are doing it, in line number q we got like in node number 5 and node number 7 we are applying the loads. So in line number 39 we have, for I equal to 1 is to size of q comma 1, and size of q comma 1 will give me 2. So we are iterating I from 1 to 2. Okay, so
Okay.
j for I equal to 1, j equal to qi. Qi is
I
like what?
believe we need just
You just iteratively, like step by step, you just apply it so that in the screen we can see it. Stop sharing.
For instance, if we have here uh, Q size of Q.
It's 2 by 3. Size of Q will be 2 by 3. So size of Q1 will
uh,
give me 2.
2, yes, it will
Yeah.
be
So
2. And
I is equal
for
to,
E, for I is equal to 1, we have J. Local number will be Q of 1. Is
it's
Q of
Q
1
of
is
1, 3.
5.
5, 5, 5. Yeah.
5. Q of
Yeah.
1 is 5.
5.
Q of 1 is 5. And we are feeling
F. In the global degree of freedom, where this 5 will be there. So 2 times 5, 10 minus 1, 9 is to 10. Like in the 9 and 10. Hello?
I know. Yeah, yes, I'm thinking about this.
2.5, yeah. 2 multiplied with 5 rather than
Yeah,
point
is okay.
9 and 10.
It
Yeah.
is location of
Global degree of freedom, yeah.
global degree of freedom. Freedom, but
So in the
in
force vector, we are just incorporating this external load. Like these were like locally, we just
so
wrote in the
okay,
element where the loads are there. We are just incorporating those things into the global force vector.
okay. So we are reading this.
So
We are
it's
reading this.
0 and minus 20. Yeah.
We are reading this and find appropriate place in the global vector f.
Yes.
So after that, it will return our global f field.
Yes. No, but see, we already have as of now we initialized it f as a 000, right?
Yes, now it is filled like
Yeah,
this.
so you'll get this minus 20 minus 10, like when we are incorporating for both eyes, like for
Now
both.
the difficult part. This is not clear for me.
Okay.
I don't. The lecturer didn't say anything about this. What is the idea behind the indices? Why we need these indices? I understand that we need to cut global matrix
Yeah.
in appropriate way, but this element of codes is not clear.
Okay. Okay. So indices of UK. UK, as told, these are like a known degree of freedom and indices of unknown degree of freedom. I'll share my problem again. Uh, so if you see the problem, okay. So what will be my first thing is UK, right? What will be my known degree of freedom? It will be what? 3?
Known degree of freedom. No.
Sorry, sorry,
It
sorry.
will be one,
1,
2,
2, 5,
5,
and 9.
and 7
Oh,
or 9.
9, 9. 1, 2, 5, 9.
1 to 5, 9. Yes.
Indices, not the nodes I'm saying. Indices, right? And unknowns will be 3, 4, 6, 7, 8, 10, 11, 12, 13, 14. Right? 3,
Okay.
4, 6, 7, 8, 10, 11, 12, 13, 14. Okay. Yeah. So now let's go to the code.
Okay.
So, okay. Indices of known degree of freedom. So for I equal to 1 is to size of boundary condition comma 1. Okay,
Okay,
boundaries.
it is the size of one,
Okay.
two, seven. It's
Let
seven.
okay. Let me see once again. Size of.
By the way, now
Hmm.
we feel that, and it should provide wrong result because we
Cause
feel.
yeah. Now saying this, I can say for sure that we need to specify only essential boundary conditions.
Okay.
Because the code is like that. Otherwise, so you can modify the boundary conditions now.
Yes.
So first, just copy that and then remove it. Why put in so
Okay.
much?
I believe we need just put. It will be easier if we just put. We need to. It's a. Sorry.
100, comma 3
E
30. Yes.
0 1
Yeah.
and 5 0 1.
Uh, no. 301. Yeah.
Zero
Then
one and
three
five
zero
zero
one
one.
and 501. Yes. Okay. Now you can modify that.
No constraint. Constraint. Yes.
Okay. Now you just run this command now initial part.
No.
Just
If you want to do it MATLAB, you need to correct this.
as a percent sign. Yeah.
Uh,
Okay. So UK finally see if UK is coming out to be 1259, right?
yes.
And this is what we came, what we did. Like unknown degree freedom is 1259 only.
You also write this.
Yeah.
Yeah.
See, 1259.
Yes. Okay.
So
Now.
now need to see like how is it coming up, right?
Okay.
So let's do it line by line. So line number 46. Okay.
Yes.
So line number 46 for I equal to 1 is to size of boundary conditions comma 1. So size of boundary conditions we applied at 3 nodes essential boundary condition. So our I will run from 1 is to 3 comma 1 is equal to 3. So I will run from 1 is to 3. It's best I write it because you'll
Okay.
take time.
Okay.
Uh, you can just add, yeah. Okay. So you see size of boundary conditions comma 1 is 3 now. So our I will run from 1 is to 3. Okay. Now
Yes.
boundary conditions was what, uh, 1 3 and 5. Okay, let's see 1 3 5. Yeah, this was constrained or not constrained. Constraint. So this one was 0 0. This one was constraint transfers may 0 1 and 0 1. Okay, yeah. Now uh, so line number, uh, can you just move up? Yeah. So line number 46 we are doing, right. So I runs from 1 is to 3. So for I equal to 1, our I1 will be 2 times boundary conditions of 1 comma 1 minus 1. That will be what? 1 comma 1 is this one.
1,
So 2 ones are 2, 2, and this will give me 1. I2 will be what? Uh,
2,
2 times boundary condition of 1 comma 1 equal to, this will give me 2. So question statement says if boundary of condition uh, 1 comma 2 not equal to 0, then UK is, you just write UK comma I1. See, as of now UK is what? Just a null vector, doesn't have anything,
yes.
right? So you're saying here. So our
We are
1
filling
comma,
this statement.
so this is 1 comma 2 is this one. This is coming out to be 0. So it's true. So our UK will convert into what? Now our UK will become uh, I1 is what? 1. So our UK will become 1. Okay. And this is, we are getting after this statement.
Okay.
Then,
I1. It's 1. Okay. I1 is 1.
yeah. Now, if boundary condition I comma 3, UK and I2. So this is also 0, 1 comma 3. Yes. So now our UK will be what? We already have UK as 1 and I2 as 2. So our UK will here now become as 1 comma 2.
1, 2.
Okay.
Okay.
And here we have this. Now it will run for I equal to 2. I equal to 2, again the same, we are now in the second column of boundary condition. For 0 it will just incorporate, like if we are having 0, this thing, it will incorporate into the UK. So for I equal to
Okay.
2, I1 will have uh, I1 will have what? 2 times boundary condition 1, this is 2,
Not
3 is
1, 2,
6
1.
minus 1,
2, 1.
5.
2, 1. It will be 2, 1.
Okay, 2,
6 minus 1,
6.
5. It will be 5, yes.
Yeah. So I1 will be 5, I2 will be 6. So UK, if you see this one, first boundary condition, so this is 0. Here it's 0. So it will incorporate into UK. So I'll get finally 1 comma 2 comma 5. Okay. Now for
Okay.
the second one, it says 0, but we don't have 0 here. So it won't incorporate into this. So our final UK after this I equal to 2 is
1, 2,
1
5.
comma, yeah. Now we will the same thing will run for I equal to 3. It will run for I equal to 3, and I1 will have as 2 5 is 10, 9, I2 as 10, and similarly UK will get as 1 2 5 9. But for 10 we won't have any incorporation. So final UK after this we are getting what? 1 2 5 9. I hope now this makes sense.
Yes, makes sense.
Okay, now let's move on to this UU part, which is line number 56. Okay.
Yes.
So 56. So UU we are initializing that, we are saying we have a null vector now. Now for I equal to 1 is to number of degree of freedom. So I equal to 1 to number of degree of freedom. In that case our number of degree of freedom total
14.
is what? 14.
14. Yes.
Yeah. And this statement flag equal to find I do UK not sorry equal to I. uh, okay, let me see. So
I never used find function.
find function says uh, we are comparing whether that's true or not. So that will give me kind of
Non-zero. It returns non-zero element. Okay.
no. So
I have
but
read that, but okay.
yeah. So if you see line number 57, yeah. So I will run from 1 is to 14. Okay. Now let's see for I equal to 1. I equal to 1. I'll just use different color. There's a statement flag find UK equal to I. Right. So UK equal to I means for 1. Let's see this one. So in UK, what do we have? 1, 2, 5, 9. Yeah.
Yes.
So in UK, it will search for the value of 1. So it will find uh, like what will this give me? It has
Let's check.
yeah.
IDUK is equal to
Equal to no first
1.
okay, yeah, answer is 1, yeah. Search for 3. So what did it give you? Null vector, right?
Yes.
Yeah. So
Don't
it's
understand. Don't understand how it works. Okay.
so if it is there, it will give me that value.
If it is there, it gives if it is
uh,
there. Oh yeah, ID. Sorry, ID you. Okay, one is there. It provides me the its position, right?
you search for see what does it give me, the index. See, when you search for find UK equal to some value, right?
And okay, I forgot this command in MATLAB.
uh, so okay, you
Okay,
got it now. Where that value will be, that gives me 1, and find will give me the index of where the values are coming out to be 1. So like
okay, return index. So the 9 it should return 4. Okay, it returns index. Okay, it returns index.
yeah, you're saying that 9 was my fourth index in UK. Hello?
Hello, hello. Yes, it returns 1.
See,
Uh,
UK had values as, see, UK had values as 1, 2, 5, 9, right? When we are searching, find UK equal to 1. Okay, so this will give me first, this will search whether 1 is there uh, in my UK or not. So when it searches, it will, this thing will give me what, 100, and this find will just give me that index where the value is 1. So 1. Now if I search like find UK equal to 9, or let's say 5,
it returns 3.
it will return 3.
It returns
How?
3.
See, This find UK thing UK equal to 5 will give me what? UK this index has is not 5.
Zero
It is
zero
not 5.
one
1
zero.
0. Now this find UK what will say? See, one value is here na. So this is 1 2 3. Third index. Third index of UK is 5. It will say like this.
Okay, now it's clear.
Okay. So now it's
If
fine.
flag
Now
does flag greater than zero,
yeah.
I'm just checking the condition here.
Okay, now let's. So if flag is greater than 0, okay. So now let's see. So let's see one thing. This flag will be what were the values? One, 2, 3, 4 values for I equal to 1, I equal to 2, I equal to 5, and I equal to uh,
Nine
9. I think. Yeah. No, 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 no. The problem,
or what?
degree of freedom, degree of freedom. 1 2 5 9. Okay, no, yeah, yeah. 1 2 5 9. 1 2 5 9. Yes, yes, yes.
Oh, if flag is greater than zero, it means that it found something.
Yeah. So see,
We need
so
cases where it doesn't found anything.
yeah, yeah. So flag will be 0 for what values? 3,
Where it
4, 6. Like we are running for I equal to 1 to 14. Remember? So
yes,
I
yes.
I equal to 1, it will have a value 1. I equal to 2, it will have a value 2. I equal to 3, it will have a value of 0. 4 0 5 1 5 will have a value of 3. 6 will have 0. 7 will have 0. 8 will have 0. 9 will have a value of 4. 10 11 12 13 14 will have all values 0. Now the if and else condition says if my flag value is greater than 0, so then uu will be what? Uu and that I value. So initially, like, okay, so I equal to 1, my flag value came out to be what? 1. And let's apply to this condition. Is it greater than 0? Yes. So uu as of now it's what?
By the way, I had compare, as you can see here. I just uh, try to compare. Look,
Okay, you just wrote everything. Yeah.
it returns. I don't understand, by the way, how it can be empty if its dimensions one over zero.
Uh, that I that's
This
a
means
deep thing
some.
which I can't. I have no.
Okay,
Okay, let's further. Let's move on to. So for I equal to 1, flag value comes out to be 1, and yeah, the flag value is greater than 0, so that means our uu will become what? 1. Now for I equal to 2, flag value will be what? 2.
no,
And yes, it
no. I believe it will be for one. It will not add anything.
no, no, it will add.
Why? Ah, sorry. One is there.
Yeah, 1259 it was there, no? See, 1259.
One is there. So flag is greater than zero.
0.
So
So,
it does not add anything here.
array, okay, it has made. Okay. Okay, okay, okay. Sorry, sorry, sorry.
Okay.
That has been like in what is this? Okay. So, oh, these were in UK, right? UK were 1259. Huh. Huh. So, okay. So this is yes. So our UU will be as it is, nullified. Okay. Now for I equal to 2, flag value comes out to be 2. So that is also greater than 0. So next statement, it will just move on to the next iteration value. Now for I equal to 3, the flag value will come out to be 0. So if condition is not true, so it will follow the else condition, and UU will give me what? 3. Right?
Yes,
Now I
right.
equal to 4, the flag value will again come out to be 0. Then again it will run for uh, else condition, and it will give me 3 comma 4. And likewise you can understand how it will go on and give me
Yeah,
the
I
values
believe
of 3
yes.
4
I
6
believe
7.
yes. Now
Yeah.
it's clear.
Yeah. Now let's move on to the partition part. See, this thing which has been written, this can also be simplified rather than writing like if and else condition. Rather, if I know my global degree of freedom, right? And I know as of now my known. So with some simplification, we can just get UU like those in terms of coding thing. Okay, let's not dwell too much on that, rather focus on the this coding part. Okay, so let's see line number 65, initialization of partition stiffness matrix. So
Yes,
KKU.
by the way, I believe it should be exist more easy way to doing that. I don't know. I'm not sure, but
No, it's there actually. This thing has been made complicated, but whatever, don't. Let's see whatever the code has been provided. So KKU is equal to zeros. I How is that? I think there is a mistake. I think.
this code for me, I just uh, I just feel this. I run the code and it doesn't work.
I know.
I just
I think there is a mistake here in the partition stiffness matrix. See, the naming is KKU, but the length of the matrix is UU and UU. So I think line number 66 should be KUU. You just change it. KUU, and
okay.
in the down that will be KU, I think. Let me see once again what was the length of KU. KU was 4 by 2. 4 by 2
It's
4 by
okay.
2,
Okay.
so that means length of
We
UU.
can check this.
No, it's correct. It's correct. No, it's correct. So are you doing it further? First save this statement so that.
Oh, sorry. I haven't run this. Sorry. Now it's work.
Yeah, so now it's working, I suppose.
KU is 10 by 10. K, KU
KUU.
is okay.
Unknowns
So,
are 10 by 10. Yeah, so KUU should be 10 by 10. Yeah, I think that is
yes.
now it's coming out. I think there was some mistake there. Okay, so that has been
Okay.
rectified. Okay, now the computation of element stiffness matrix and global stiffness matrix. So for element stiffness matrix, for the line number 70, we are iterating over each element. So first element for equal to 1 is to number of element we have, right?
Yes.
So number of element we have 6.
Yes.
So first element, when we take first element, that, yeah, so when we take first element, 9 number 72, so element 1 comma 1, element 1 comma 1 will give me the first one, and element j1 will give me element 1 comma 2 as 2. These are what we in the element connectivity matrix we had, like for first element the node connectivity is 1 comma 2, for node element 2 node connectivity is
So
2
it's a
comma
local nodes.
2.
Local nodes.
Yeah, I1 is local node, but the answer which is giving out to be the global node. I hope you are getting.
Okay. Yes. No, it's not. It is not correct.
Okay, so I1 J1 is clear. Now the length of element is what? We just uh, subtract like J1 minus I1. That the absolute length will give me the length of this element.
Okay.
Now element stiffness matrix. These are the standard formulas
Stiffness
associated.
matrix for beam element.
Yeah. To make it clear, this is just for a horizontal element. Like we are not taking an element which is having an inclination within horizontal. My element in consideration is an horizontal element.
By the way,
Yeah.
here, uh, the first, when I saw my problem in this finite element method problem assignment, I thought initially that we have different queues
Different.
for each. Yes, look, I try to explain by. Can you see my screen
Yeah. Let's stop sharing.
here? This I thought that 20 kilonewtons by meter it is a Q for the first section, and 5 kilonewtons by meter is for the second and for the third. I thought
Uh,
that this Q is different for each element,
okay.
and when I tried to correct code, uh, I was
I
unhappy how to fill Q for each section.
I think the problem, the way they have given the code fx equal to whatever you substitute it, it will give me for throughout the length rather than for a
Yes,
particular. So,
yes.
so the problem is made like that. I can't. You have to modify the code accordingly.
In this part, I thought how I need to fix the code to have each queue. I believe
Okay.
I need to use distribute it for element here.
I think
Now I believe.
if you make changes, you have to make changes to other thing as well, because the way the coder has taken that effects into effect into other thing, that also need to be taken in account. See,
Yes, yes.
so
Okay, I believe it's okay right now. I think
can you show the question again? This the assignment question.
yes.
Go up. Let me see. Consider the Euler Bernoulli find each segment of the beam is described with single angle.
No, it was my mistake. I understood after that that we need to consider it as a moment here. So
That's a
I
kilonewton
confused.
meter. Yeah,
Yes,
yeah,
kilonewton meter. I just confused here.
yeah. Okay. Now let's move to the coding part so that we can complete it as soon as possible.
Okay.
Now, the, so we are into the element stiffness matrix, line number 79. Yeah. So there also we don't have any issues.
We can try to.
No, rather, wait. Don't run everything. Uh, type E equal to 1,
Okay.
type, and then select from JI1, line number 72 to line number 85. Yeah.
Okay.
So it ran properly, right? Now, eh, and then copy from line number 88 to 94.
Okay.
Run it.
Let's try.
Yeah. Now, just go up, like where I told you to copy, like where you first wrote equal to 1 after that. No, here in the command section. Yeah, yeah, equal to 1. So see, I1 equal to element E comma 1. You just hover that over I1, I1. See what is the value of I1. I1 value will
One.
be 1. I
One. Yes.
Yes, and J1 will
Uh,
be 2.
two.
Yeah.
So
So
first element.
yeah, first element I1 is my see locally I1 is my local node 1, J1 is local node 2. Okay.
Yes.
So first element local node 1 is my global node 1 and local node 2 is my global node 2.
Yes.
Now length
Yes.
of this element, then element stiffness matrix, then element load vector. Element load vector is this is directly distributed. Is that load has been distributed? So for UDL just 0.5, like it's a UDL, right? So UDL WL by 2, WL by 2, it's been distributed to the load nodes, and the
UDL.
moments
What is what UDL?
UDL, like uniformly distributed load.
Yeah, a uniformly distributed. Yes.
Yes. So see fx is there, na? Yeah. So see the first zero point 0.5 into h. What is that?
It is
W.
a. For, okay, this is a formula for uniformly distributed load.
Ha,
Yeah.
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 So,
Yes.
so,
Yes.
so see, the first thing will be WL by 2. Second thing would be the moment thing minus WL square by 12. Then again WL by 2, then WL square by 12. So that is the thing.
Yes.
Okay. So this way we have got the FE, that local uh, element load vector FE, that
Yes. I
degree of
see.
freedom.
After that, we after completing these lines, we filling
We
our
fill these
global
to
force
that
vector
global
with
force vector.
uniformly distributed.
Yeah. Earlier we
Yeah.
fill everything, like for externally applied load, we just filled in the global force vector. Now we are just filling for this UDL part thing into the force vector in the
Okay.
line number 93. Yeah. and
Yes.
line number 90, 91 all are related to element stiffness matrix. Like all the element stiffness matrix we are substituting into the global stiffness matrix. So do you have any doubt there?
No.
No. Okay, so this way we repeat for each elements. Now let's move on to line number 97.
By the way, it's locally updated step by
Yeah,
step.
yeah, yeah. Locally, everything we are updating, and then we are assembling, like we are adding, right, to get the global thing. So in line number 97, if you see,
If the vector.
yeah, element
If
degree
the
of freedom
fact
vector.
element degree of freedom vector. What does it mean?
It will give me like what will be the global degree of freedom of each nodes. So see, if it is coming out to be 1, 2, 3, 4.
I
For
just want to
check for element 2, check E equal to 2,
for yes.
then again run all the command, or rather just yeah, okay. No, 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 not there,
No,
not there.
no, this. Okay.
Till 94, till 94.
Okay, thanks.
So go up now. So now it's 3, 4, 5, 6. Because element 2 has my nodal degree of freedom as 3, 4, 5, 6, right?
Coders are genius, guys. I just okay. Great.
It's fine now. So
It's fine.
can we move on to this 97 now?
Yes.
Now this is partitioning of stiffness matrix and load vector. So uh, length of length of
Ten. It's 10.
yeah, yeah, it's 10. So we are just assembling. We had the global stiffness matrix as in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 uh, in an original order. Now we just need to modify this in terms of in one block as KKU. We just have to partition the blocks, right? For that, he is trying to assemble the stiffness matrix in those way, right?
Right.
Now see the line number 100. Okay, let's see first for j, line number 98 is for j equal to 1 is 2, that will run till 10. Now our j is equal to 1, suppose. So stiffness matrix line number 101 is giving me I runs from 1 is to length of again uu, that is 10. So kku is I comma j kg of IDUUI and IDUUJ. Okay, so this thing like line number 101 to 103. This will give me a row of elements.
We just feel we just cut our global matrix here.
Yeah, we are just picking out those elements for the KKU block.
Yes.
Similarly for KUU and ultimately that global force vector is also need to be modified, right? Up and down.
Yes.
So
Interestingly, how we KU here. It's more interesting. Okay.
oh, okay. Let's see. Is it correct or is it wrong? KKU. I think here it should be KUU.
Yes.
Yeah, KUU, and in the down it will be KU. Yeah. Yes. Okay. Okay. Now FKJ. So FKJUU. Now it's fine, right?
I believe
Can
yes.
we? So can we now? So after this, we'll have everything partitioned, like KUU, KK, KKUU, KKU. All things have been partitioned now. We are. You run everything now till line 111. You run everything.
By the way, interesting why we need to minus here. It was unclear moment also.
Okay, I'll tell you. Don't worry.
We just run this.
Yeah.
We now have indices. Okay, we need to do this, I believe. I believe we need to again
Yeah.
initialize.
Uh, it's best you just copy from the beginning and run till 111
Okay,
so that we don't miss anything.
but I believe there are a lot of. Oh,
What happened?
we
Okay,
we
okay.
did.
Uh,
I
okay, no problem. I'll just iterate. You just first copy all those things.
there are a lot of moments there. There was a lot of moments here.
Okay,
There.
no problem. I'll iterate. You just copy those things first till 111. Yeah, and then make the changes. So first change was you made the number of node as to be 6. Yeah, that's fine. Yeah, okay, that's also fine. Now in the boundary conditions part, yeah, we had to make change. So 1, then 5, no, sorry, 3, 3, node number 3, 0, 1, yeah, 501. That's it. Now other part, in the external forces also we need to modify. Okay, so in the external forces, in the node number uh, 5, 5, it's 50 minus 20, yeah, and in 7, it's no, no, 7, 7, yeah,
7.
7, yeah. Okay, now,
Ah, we are solving your question. Okay.
yeah,
Why 7 then? Ah, node 7. Okay.
okay, now fx will be equal to 12, minus 12, yeah. Now it's initialization. Uh, did you make that changes also, KUU and KKU earlier, where there was a mistake?
I forgot where I changed it.
Uh, okay, it's down. No need to worry now. Yeah, when the initialization of partition it will start, then yeah, here KUU KKU. Yeah, it's fine. You change that comment one. Yeah. Now again, more.
As you can see, we can mm, the layer is not suitable here. I cannot make it bigger.
Can you just maximize that command window? Like you can drag and make it bigger, na?
No, actually this in this version I cannot do that.
Okay, okay,
But I believe we can do it in MATLAB.
okay. From next time onwards, I'll be ready with this code stuff also, so that you guys don't have any issues. Okay, you can now run. I think. Oh no, still commands.
How we correct this?
Hmm?
Is
Yeah,
this
yeah.
okay?
Yes, 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 yes.
Need to check.
Now run it.
Comment section.
I
Comment section.
better. Yeah. I suppose that KKU is also corrected in your code. Other, don't forget to correct it there also.
Okay, let's check.
Yeah. KUU should be 10 by 10. So is it size of
It is.
type size of KUU?
It is. I see this, as you can see.
Okay, okay. Yeah. KUU is 10 by 10 and KKK must be 4 by 4.
This is wrong, as you can see.
FK.
FK, this dimension is not okay.
Okay, the I maybe in the coding part they have must have transferred it, like transpose it.
Let's check. No,
No, that I think naturally they are taking into account how to solve that thing. Then solve.
I don't know this command. I believe it is outdated command from very old version of MATLAB. Okay.
Okay.
No, by the way, it's okay.
See, one thing you can do. Uh, just
Why minus here?
okay. Yeah, sure. That is easy. Hmm. Mm,
By the way, why they use? Ah, sorry. It is not about solution.
I think
And
still there is some mistake. Let's say solution of unknown displacement. Uh, okay, let's do this.
unknown. Why it is unknown? Unknown is it should provide us with.
You okay? You see my
Look,
solution?
look. From my perspective, here should be KUU. Here should be FU,
Yeah, yeah.
and
It's
we.
better we try to do this. I am trying to do this rather jumping.
You're writing something.
Yeah. Okay, I'm not sharing now. Let's share it.
Guys are
They have left actually. No
they have
problem.
left. Okay.
No problem. They can view. These videos will be uploaded. Hopefully. UK F K and FU. Right. Okay. I'll just write these things as
Abraham said to me that
RK. Yeah.
it's, it's difficult to where we need to go.
Yeah. So I hope after this you guys won't have any problem because I went line by line, right?
Right.
So just saying UU plus KUK.
But as you can see, there are some mistakes.
Yeah, there are some. I cannot deny on that part.
So what we should do in this case? We need to try to fix this code, or what?
You can just raise this issue in the discussion forum so that other
Oh,
other TA can take
you
on.
know that I'm not asking anything there because community TA for this is very, I don't know,
Okay, okay, leave it then.
not well prepared. They're not prepared
No, but
to.
it's best you just post it so that other people can get benefit also. You don't ask, just post it that there is an typo or something in issue with the code. Okay, let's do this. You're seeing my screen, right? So we are having this part. We know this part. We want to solve this one, right?
Yes, yes.
Okay, so
VK is equal to 0.
hmm? No. Right now we won't directly make it zero. Let's do it line by line. Okay. Let me recollect.
How we usually resolve it? We usually invert KUU and multiply by F known.
RK UK UU. Mm-hmm. Okay. See, let's.
Am I right?
Yeah, what are you saying?
The next step we need to invert KUU and multiply it by F known. And the second,
We generally do like this. UU, then
yes, F known.
RK minus KUK UK.
But VK is known.
So in what RK.
Ah, you mean that VK can be in homogeneous also.
Uh, wait. Huh. So you're saying something?
You mean that we have VK in homogeneous conditions also? We can have in homogeneous conditions. You mean here?
Huh. Yeah. Better not substitute it right now. Write it in a general sense, then we just substitute it zero. Okay, so if it's there like this, KK known 0 0. Still
Where
not.
zero?
Yeah, missing something. Let's say.
By the way, in all codes, I noticed that they use minus sign in all codes.
Mm,
It was very suspicious and strange and weird.
I thought like it would be coming through this. Okay. What was the code there? KKUFK.
Solutions for unknown displacement.
Uh,
It's very strange.
but
Why the
in
need? KU is not even orthogonal or what?
what are you saying?
KU is not orthogonal. Is not a square matrix.
KUU. It will be, na?
K,
KUU.
but they wrote KU here, as you can see.
KK. Oh, so that will be that needs to be modified. That should be KUU.
Why minus?
Yeah, that's still in question right now.
By the way, I can share you with you trust example, and you will see that there will be minus also. And then again KU. Strange.
This is trust.
Yes, in trust example they also use minus.
Why K U. Oh, if U is equal to K U minus uh, mm, 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 Y minus
Okay, we need to ask this about. We need to ask the person who called this. What did he mean? By the way, he used minus ku here, and here he also used minus ku. So it's again we need to
change
look,
there.
look, look. Ku. He is using ku again.
That should be actually the right side he is doing correctly, but on the left hand side he is mentioning different. That should be K U U.
But he look in terms of this
They,
person.
yeah,
This is correct.
yeah, but that should be K U U. I'm saying.
I just said about this because it is consistent with his code.
Yeah, the way, it's consistent with the code, but with the notation that we normally use, that is not consistent, isn't it?
Yes, yes, it is not consistent.
Yeah,
Yes, it is.
so it's better to modify it. Then in the support reaction, you write K K U. It's K U U, right? You write K K U. Yeah.
And I believe there is no minus.
Let's try it.
I,
What kind of displacements we are getting? With that, we can
I
see, na?
believe for next time I need to also be more prepared in this code. I plan to fix it
Yeah.
and run it MATLAB, but I don't know where is the mistake, so
Okay,
I
I'll
wrote it myself.
uh, in the next assignment. Are you aware which code we are using so that I'll be prepared with that?
Yeah, yes, he shared some codes for the next assignment. Give me. No, for the next assignment, there we have no problems with code. But
Code.
for the week
Eight
eight,
week.
I believe we should have some code, but we have not. I don't know why.
No, maybe
There's a
in the quiz they might be saying use the code provided earlier. It could be. I'm not sure.
we can see. Have you solved, by the way, some transient problem with finite element method?
I know. I would say no because
What
that's
about hyperbolic equations?
that's not my field of expertise. But I will do this.
Uh, I, I I asked about you answered the first questions today. First question was about Euler what
Euler-Bernoulli.
Euler not
Euler-Lagrange equation.
Euler Lagrange equation with several variables.
Yeah, I told you.
I asked about this because it might be my questions now.
Okay,
In
so
some article, I believe my Lagrangian depends on several variables, so I asked. But now
okay,
I come up with that my equation actually hyperbolic, and I don't even have opportunity to write correct.
okay.
How we say that?
For multiple independent variable, I just in the beginning of the class I explained earlier. I'll just show it once again.
You know, can I show you something? Do you see my
Just,
screen?
just a minute, just a minute. This one I shared. I explained it earlier. This Euler-Lagrange equation for when we are having more than one independent variable. So this is
Yes.
how we solved it. Okay, so as I told you earlier, like I know for sure what was the Euler-Lagrange equation coming out to be. So this
Hmm.
was the. So today I explained like how is it coming out to me. So
Okay.
I have that. Okay, so you're
I
saying
I, I,
something.
I, I asked because you know what? I uh, I tried to solve this problem. If you have time, I believe
Okay,
we
okay,
need to finish with code because you don't know where is the mistake. I also don't know. We need to ask
okay.
for
Uh,
community. I don't know.
let's finish the code today and do it. Then I will just for audience people, I can just uh,
Okay.
end the session and then we can continue further
Can
discussion
we
if yeah.
can we finish if we don't know where's the mistake?
Yeah. So let's do it. That
Okay,
is
let's do it. Let's do it.
so earlier it
I
was.
need to
Do remember that earlier it was minus. We have removed the minus sign.
let me do it because I feel that I need to do that.
You remember q we have to change. This is minus 12. For q also we need to change q boundary conditions also 1301501 and here it was 5 0 minus 20 then 7 minus 10 0. Yeah.
Okay. Okay. Abraham said, "Should we know?" Ask me, "Should we know how to Scilab work?" I tried to explain to her that we need to actually do it in MATLAB because Scilab is just free version of MATLAB.
uh, I normally use MATLAB because in our institute provides that. So I
I understood why they did that. They just did that because have a problem with MATLAB because it is not free.
yeah, yeah, yeah.
Okay, yeah, I believe I I believe I um,
Made
put
the change.
all commands
Okay,
there. Yes,
let's say
here's a KUU, KKU,
yeah, it's fine now.
it's
Okay,
KU,
len
KU here.
no, 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 it's fine.
It's KKU.
Yeah, it's okay now. This one you we do remember that in 114 we have removed the minus sign. Earlier it was
I
minus.
removed.
Yeah, yeah,
Yes, we removed here.
yeah. Okay, further down. So displacement. This is how they are coming out theta. Okay, fine. Next down. Post processing exact solution. WX. These are like comparing with the exact solution. So 135 it's fine. Next down.
I'm not sure that this exact solution is okay for us, for our problem.
Uh,
It's for their problem. They
okay.
have two-element bar, two-element cantilever bar in the lecture.
Okay, rather than doing post processing, we can only see till there, right? What's our displacement coming out to be, whether rather it is positive or negative. From there also we can understand how the solution is behaving. You getting what I mean to say? Uh, till 129 you better run. Till line number 129 you run everything. Rafael? Hello? 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 Rafael, are you there? You're still not audible even if you're speaking. But I can't hear you and you're not audible. Hello? Hmm, mine is also working perfectly. Uh, okay, I'll try a different thing. Just give me a minute. Mm, yeah, hello? Yes, now I can hear you. Yeah, please share your screen. I cannot see. Yeah, yeah. Can you just again reshare it, your screen? I think there is an issue with my system now. Then again reshare it. Actually, I can see when I use a different. I don't know what the.
One minute,
Just
I
okay,
check.
give me a
I
minute.
don't know what. Okay, give me a minute. Yeah.
Okay, now I
Okay,
can
now
see.
I can see.
I don't know why,
One zero
One
zero
zero
one
but
zero
it
five
one
doesn't work.
five
505.
505.
Doesn't.
Oh, I
Oh,
told
told
you
you
to
to
run
run
till.
till
Go down, go
go
down,
down,
go
go
down.
down, go down.
129.
Yeah,
Yeah,
it didn't
it
work.
didn't work.
No,
You better
You
run
better
I
it
don't
run
know
it
once.
why.
once.
Run it
Run
once
it
again.
once again.
As you can see, it didn't work with zero. Come up with zeros.
Operator
Operator
non-conformant
non-conformant
argument.
argument.
Where was it?
Where was
Insuf
it?
is not working.
Okay.
One.
Yes, yes.
Yes, yes.
Okay, we transposed here. Let's do it again.
You save
You
it.
save
What
it.
is a K? What is a KU? Let's check these dimensions. KU is 4 by
KKU
10
is 4
KKU
by 10.
4 by 10
And UU
and
KQ is 1
is
by
UU
10,
is
UU is
UU
10
is
by 1.
10 by 1.
10
So
by 10,
So
10 by 1 I
10 by
will
1
say.
I
10,
would say.
10 by 1, 10 by
U.
UU.
Where
U,
is U?
Where's
where is U?
where it is? Where it is?
Stupid.
Stupid.
U.
Why is it
Why
still
is it
not
still
here?
It is
not
not.
here?
I don't
IDU.
know.
ID.
It is not identified.
Okay.
Okay,
See.
see,
Let's
let me
see.
see.
Mm,
Mm,
okay. There
okay,
are a lot
there
of
are a lot of errors
in the
in the
code.
code.
UU.
UU.
Here it is.
UU, it's there,
UU,
na?
it's there now.
In line number
In line number
114.
114.
One number
114.
114.
114. Ah, okay. We have a dimensions problem, therefore it is not identified.
Yeah, we
Yeah,
better
we better
do it once
do
again.
it once again.
I wanted to put some semicolons
Okay.
Okay,
because we obtained some
Unnecessary.
unnecessary.
unnecessary elements. Yes.
129, I think.
129, I think.
129.
129.
Yeah.
Yeah.
Still some
Still
error
some
is
error
there.
is there. Huh?
No, it's
No,
It's
now it's some here.
okay.
okay.
I believe there is some errors. Why we have rotation in the first node? Ah, sorry,
No, no,
No,
those are
no,
it's
no.
not
like
Those are
rotation.
like
those are
those are
displacement.
displacement.
Rotations are
Rotations
theta.
are theta.
Yes, we have a displacement there. There is no displacement.
See, there
See,
are
there are
seven
seven
displacement and seven
displacement and seven
rotation.
rotation.
So
So
W1
W1
at node
at
1,
node 1,
uh, W and theta
W
are
and
0.
theta
So
are
that
0.
is
So that
okay.
is okay.
It's okay. It's okay.
So and in
And
By the
in
way, can we check
no, we can
no,
see
with
we
your
can see
solution?
the.
uh
Uh,
okay. Let me
okay,
see.
let me see.
Let
Okay,
me
let me
see.
see.
What was
What
theta
was theta
actually?
actually, right?
Mm,
Mm,
It's not okay for me that it is pending. Here is some
where is it
where is
bending?
it bending?
pending. Do you see there's it's not correct as coding.
D right.
D, right?
So
So
change that to
change that
It's
to
it.
our matrix so solution is growing with time. I believe it's not ideal for coding here. It's
So
not
so
ideal code written. Okay,
just
just
give me
give
a
me
minute.
a minute.
Theta b.
Theta B.
What is that
What is
theta
that
b?
theta B?
Theta b
Theta
means
B
1
means
2 3
1, 2,
third
3, third
minus
minus
2.85, right?
2.85, right?
So that is
So that
correct.
is correct, I think.
That is
That
correct.
is correct.
okay,
And
nice. There are
reactions, have we
reactions,
found
have we
that
found that
reactions are also
reactions
there
are
or
also
what?
there or what?
Support
Support
reactions.
reactions.
let me see where is this.
Support
Support
reactions
reactions
are there.
are there.
Wait,
Wait,
down,
wait,
down,
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 down, down,
down, down,
down,
down,
down,
down,
down,
down.
down, down.
Slowly, slowly.
Slowly, slowly.
This fu.
FU, yeah,
FU, yeah,
117.
117.
Yeah,
Yeah,
16.2857.
16.2857. Mm,
Joint B and
joint B
C.
and C.
FU
FU.
Minus.
Uh,
58.86.
58.86.
It's correct.
It's correct.
That is
That is
correct. And
correct. And
6.857. That is
6.857.
also
That is
correct.
also correct.
16. Our
16.
solution
Our
is
solution
correct.
is
This
correct.
is the
This
one.
is the one.
Nice.
Yeah.
I'm happy with that.
Yeah.
Yeah.
At least one code
Okay.
Okay.
finished correctly.
One thing
One
we
thing
can
we
do.
can
Just check
do.
it.
Just check it.
Just
Just
that they
that they
where we
where we
put
put
plus sign
plus
instead of
sign instead of
minus.
minus.
Just try to
Just
put
try to
minus
put
and see
minus
what
and
it
see what
happens.
it happens.
First, copy
First,
this
copy this
displacement values
displacement values
before running the
before
command.
running the command.
Before running the
Before running
command,
the
copy
command,
the
copy the
initial values
initial
what
values
we got
what we got
right now.
right now.
This W
This
and theta,
W and theta.
at least W
At
and
least
theta.
W and
Okay,
theta.
where I create a problem with the first is equal to w here and the theta one first again first theta what first theta first. Okay,
And
And
if you are
if
copying
you are
it,
copying it,
better copy
better
for
copy
FU
for
also.
FU also.
FU,
okay,
FU,
FU first.
FU first.
first if you
Yeah.
Now run.
Now run.
Yeah.
Yeah.
You just
You
change
just
their
change
minus.
their
Yeah.
minus. Yeah.
We can
We can
compare
compare
the
the
solution is what.
solution is.
sorry, there's a clear and clean here.
Oh shit.
Oh
Clear and
shit.
clear.
Okay.
It restart
Okay,
everything.
no
Okay,
problem.
no
We can
problem.
see
We
the
can see
answer
the
still.
answer
We
still.
can
We
see
can
there.
see there.
2 point.
2 point.
Okay, so
Okay,
here the
so here
theta
the
b
theta
it's
b
coming
it's
out to be
coming out to
plus
be plus
rather than
rather
minus.
than minus.
So there is
So
a sign
there is a
change
sign
problem.
change problem.
Okay,
Okay,
and
and
reactions are also
reactions are
coming
also
different.
coming different.
No, so it
No,
will
so
be
it
plus
will
sign
be
only.
plus sign only.
Don't make
Don't
it
make
minus.
it minus.
Okay, so you
Okay,
better
so you
post it
better
in the
post it
group.
in the
The
group.
actual this is the
This is the
final
final
code
code
corrected one,
corrected
right?
one,
You
right?
better
You
post
better
this
post
in
this
the
in
discussion
the
forum.
discussion
You say
forum.
that
You say that
there were some
there were some
typos.
typos.
You can
You
just
can just
But
say,
if I need to, if I will post this, if I will post, I need to again to change my conditions for their problem, the problems they have in lecture.
yeah, you can
yeah,
do
you can
na
do
so that
na,
you
so that
can
you
also
can
get
also
acquainted
get
and
acquainted
get
and
confidence
get
that
confidence
now you
that
have
now you have
now you can do
now
at
you
least
can do
one
at least
code
one
at least.
code at least.
Okay, I will post.
Yeah.
Yeah.
Okay.
Okay.
Okay, so
Okay.
at
So
least
at
one
least
problem
one
solved.
problem solved.
Now we
Now
can
we
end this
can end
session.
this session.
Thank you all
Yeah.
who
Yeah.
reached this position who at this session.
Yeah. Okay.
Yeah. Okay.
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 Bye.
Bye.
See you in the
See
next
you in the
session.
next
Bye.
session.
Take
Bye.
care.